talking to you. I was talking to you.
Wait, what?
I said, I'm talking to my best friend Casper because.
Do you think about what you say?
Okay.
What you say?
Regardless, hey, I need you to get logged into your laptop like I've been asking you for the past 4 minutes. I need you to get onto Desmos. I need you to get your homework sheet out and to get combining linear functions out. And if your name is Kelsey Barksdale, you need to get that mask up over your face before I come unglued. Thank you. We probably are getting rid of masks this Friday. I have no idea. We don't get to make that decision yet. Peyton, it seems we're missing your entire group. Jump into whatever group you want.
Oh, we already said it's not. I cannot because there's people above here.
No, there's not. There's 3 here and 3 there. We can move backpacks.
No,
Move
not
me into a
unless
group.
I say so.
Huh?
I don't care, just move me into a group.
All right. Kelsey's got you.
No!
Why are you moving your stuff then? I assume that he can move there.
No, you were gonna tell me you can move my stuff.
I don't care.
Peyton's in group 4 for the day. Woohoo! All right.
Oh no.
So I need you to have your combining linear functions task out. I also need you to have the homework sheet out from yesterday because we're going to look at this number 2 or part 2 from it because you need it. Okay. And Desiree, this homework that's right here from part 1 is for an accuracy check, so you do need to do that 6.2 homework at some point, okay? All right. You got 30 more seconds to get out the materials you need, but then we need to get started.
You just say combining linear functions.
Combining linear functions and then this homework sheet that I gave y'all yesterday because we're going to go over this problem.
Oh, okay.
And if you did not turn in your homework today, you need to get that accuracy check done ASAP. Did you turn that sheet in too, Layla?
Yes, sir.
My bad. It was just the 6.2 that you needed to turn in. All right, Corell. Part 2 about Doug and Laura selling cans of soda to raise money for a school dance. And Doug sold 4 less than 3 times as many cans as Laura. Together they sold 300 cans. Which system of equations could be used to determine D, the number of cans Doug sold, and L, the number of cans Laura sold? What answer would you pick? Or did you pick? The fact that you're staring at the board and not, the homework tells me you didn't do this problem? Corell, you gotta do your homework, man.
Yes.
It's a non-negotiable. Kelsey, what'd you put for this one?
I put C.
C?
Yeah.
Okay. Peyton, what about you?
I put A.
A? Talia?
A.
A? Shelby? Layla?
C.
C? Okay. So we got a little bit of a differing of opinions, A and C, and that's totally okay. Now let's
Yeah,
talk
that's
about it. Huh?
You didn't answer for her?
I did ask Talia,
Oh.
and Desiree wasn't here yesterday, so she just got the homework problem.
Okay.
But I could call her out if you want me to.
No, I
Would that
thought.
make you happy?
No, I thought I didn't know she was not here yesterday.
See, this is why you pay attention to your own business instead of trying to get up in everybody else's
No, I was
business.
just asking because you were asking certain people that were not the rest of the class. I was just confused. It was just a question. It's not that deep.
Felt like you were trying to attack Desiree. That's all I'm saying.
No.
Anyways, moving beyond all that. Okay, we got a word problem here. Most people who I did see even actually have an answer. Yes, Julia?
C. I thought I put A, but I put C because I already rated A, so
Gotcha. Alright, so Peyton's the only one with A at this point. Everyone else has got a C. We'll look at it, but here's what I want to discuss, alright, and look at with this one is, I saw a lot of people who picked answers. I see Layla put some information down. Did anyone else actually take some time to think about why they put the answer that they did or show justification?
Well, I thought about it, but I didn't actually put it on the justification.
How well is that going to work out for you, Peyton, in this class?
Because I annotated, so I just put that as my assumption.
Okay, now when you say you annotated, what do you mean by that?
So it says that, okay.
No. You're going way too far. When you say annotated, what did you do?
Okay, I read through it and then I picked out the important parts, sorted through What
Right,
did-
that's all I'm asking you. How did you show what was important?
Underline it.
Okay, what did you underline?
So I underlined the fact that they had 300 total, right?
Okay,
So-
together they sold 300 cans.
Also underlined D for Doug and then L for Laura. So I knew exactly what I was looking at.
Okay?
And I also looked at the fact that Doug sold 4 less than 3 times what Laura did.
So I want to point this out. Will annotations like this hopefully help us get the correct answer?
Yes.
Yeah, but I'll go a little bit further. And so this is a good start. Now, I want to point out, everyone then did D plus L is equal to 300. Where did we get D plus L equals 300?
Because it's Doug plus Laura is equal to 300 pounds.
Right, together, meaning we are going to add them. So Doug plus Laura equals 300, right?
Actually, it would be C now that I'm looking at it.
Okay, why do you now switch to C?
Because it says, I guess I was just reading it wrong, because it says 4 less than 3 times.
Okay,
So 3 times would be the bigger number.
so 4 less than 3 times, and I like the way you're saying that. 3 times something would be the bigger number,
Right.
and we're going to go less than that. Notice, if I say 2 less than 5, now we'll make a note. It doesn't necessarily have to be the bigger number, but if I say 2 less than 5, what is 2 less than 5?
3.
3, right? Meaning I start at 5 and I subtract 2. What would be 2 less than negative 3?
-5.
Negative 5. Notice, it's not just, hey, which one's bigger, but it is the idea that when it's less than, you're going further to the left or subtracting that amount. Yes, sir.
I meant to ask you, but you have your S1 on the clock.
The homework sheets? Yes. Hold on a second. So yeah, did my laptop die?
Yeah, seizure.
I think my laptop died. Thought I had plenty of charge. That's unfortunate.
Guess no math class today.
That's not true. All right, we're gonna come back to that in a second. Go ahead and make sure you're in Desmos and log in and get started on Desmos. We'll come back to that problem in just a second. Because I think we were working on the sliders yesterday, so start back there.
True.
You should be able to see exactly where you stopped because you'll see the notes. Desiree, go ahead and log into Desmos and put in this code, okay? I haven't had my laptop die on me in a minute. Yeah, that's all it was. Okay, so while I'm getting that fixed, make sure that you've played around with the sliders. Make sure you have filled out what slide 8 says. What you think you need to put in for slide 8. So you should be able to explain what A, B, C, and D do or represent in that.
What? A, B, C, D.
You okay?
Now, I will say this should not necessarily be a silent activity. You all should be talking about it and make sure you all
Hey,
have the same ideas.
give me your ideas.
That's not what I said. You should be talking them out so that you come to the same idea.
Okay. Well, how do I get back to what I learned yesterday?
What
If you logged in, it should already be there. Alright, I lied, I'm already back. Sorry guys. So, anyways, Doug sold 4 less than 3 times, so notice 3 times L minus 4, that'd be Doug. So everyone should have C. That is important because we will come back to this problem later this week. Alright? So make sure you have the correct system there and that you are paying attention to how we annotated to help us get to that system. And then we're going to look at our objectives and then get back to linear functions. So, objectives. We are still trying to construct viable arguments, which does not mean, Kelsey, hey, give me your ideas, because it means each of you are coming up with your arguments, your beliefs, and coming up with evidence for them.
Well, I was trying to give him some of his ideas and not some of mine.
Okay, just making sure we're all clear on that, right? But
That's what that was.
that's what that was.
It
So
was.
we need to be all coming up with ideas. You all have brains and are good, capable of great thinking. Do it. We're trying to find patterns, right, and express that regularity and repeated reasoning, showing that we can do it over and over again for these ideas. right? So to help Desiree get caught up a little bit, because we already did some of this and you were gone yesterday, when we say combine linear functions, what do we mean by that?
Put them together.
Put them together, right? It's literally combine. What operations are we combining them with?
Plus,
Plus,
minus,
minus,
times.
just for you, right?
Divide.
Yeah, I don't know how I do the divider, like. Okay? So we're going to be combining linear functions with adding, subtracting, multiplying, and dividing, right? And so from that, we already made predictions, and I made this note to 7th period, and I think I should tell you all this as well. Yesterday when you were doing predictions, what you were really doing is you were using some ideas that you already know to help you make a prediction or make a hypothesis.
Educated guess.
Then you could also say educated guess. There's a reason I'm saying hypothesis though.
Okay.
You are now about to conduct an experiment to test your hypothesis.
Oh my jeez.
OMGs, right? You're testing your hypothesis to come up with conclusions, seeing if your predictions, your hypotheses held up. Mathematics is just a language for the sciences. And so the same things that you do in your science classes are honestly what you do here. Develop hypotheses, carry out studies to see if your hypotheses hold up, and then you refine your ideas based on that. All yesterday was coming up with predictions or hypotheses, right? About when will you get a linear, quadratic, or exponential from different combinations. All right. Is everybody into Desmos?
Yes.
Okay. Desiree, are you still working on it? Huh? Oh, you're in? Perfect. Okay. So yesterday, when we looked at these sliders, right? Why is my internet not up?
Because it's telling you not to do this.
That's God's sign that we should.
Oh, there it is.
No.
Nope, we're good.
No.
Didn't even have to do anything. That says God's like, nah, Kelsey's wrong. Teach him things, Mr. Kenny. That's what I heard. Okay. So what we're looking at, or what we ended, nope, too far, was looking at how the sliders, y'all don't see anything there. They're like, wait, Mr. Kenny. Got it. Okay. So we're playing around with these sliders looking at f of x equals ax plus b, and we were looking at g of x equals cx plus d. What were the key features we said we were supposed to be looking at for these two different functions, or these two different equations and
The
graphs?
fact that they're in the same form of line.
Okay, they are in the same form of a line. What form of a line is that? I mean,
Linear form of a
they,
line.
they are linear functions, but what form of the equation of line are they in?
Mine is supposed to be
What is that called?
slope,
Slope,
intercept.
intercept. So what are the two key elements we should be thinking about?
Slope and intercept.
Oh, which intercept?
The y.
Okay, so 1, slope. 2, we should be looking at the y-intercept. Did we have a concluding discussion about those two things, or did we just stop at
Somewhat, yes.
somewhat yes? What did we discuss?
I don't remember.
Oh,
Oh. Well, then probably go back over it.
yeah, probably. Okay. So tell me this. You see this A right here?
You slip the up,
Okay.
but it stays the same.
Let's move that.
Yeah.
So what is the A effect?
Switch the line.
What about the line?
It's going clockwise. Just kidding, you can do it anyway.
Y'all are ignoring the two key elements that you already said
Oh,
we
it's still the
discussed.
same slope. It's still the same. Still the same slope and the same y.
Wait, when I'm changing A, it's the same slope and same y-intercept?
No, it's the same slope with a different line.
Oh, okay. Same y-intercept and different slope.
Shelby, why are you putting your head down?
Oh, okay, but it's the slope. It's changing.
Yeah, I said that.
It's-
After.
After, so which one is it? Is A my slope or my y-intercept?
A is your
Peyton,
slope.
look at it.
I mean,
A is the slope, yes.
Okay. So we notice that this is affecting my slope, right? So what is this B affecting?
the y-intercept.
Yes, y-intercept.
Okay, we all agree on that?
Yes.
Okay. Using that information, any predictions about what C will affect?
The C will affect the slope and the B will affect the y-intercept.
Okay, what tipped you off that that was the slope and this is the y-intercept?
Same formula.
Because it's the same in y because so it makes plus b.
Okay, we want to notice that A and C are literally the slope. B and D are literally the
Y-intercept.
y-intercept. I need you to pay attention to this because this will make your life much easier. I want you to notice right now, what is my value for B on f of x?
5.
5. What is my y-intercept?
2.25. Just kidding, jokes, haha, 5.
5. That y-intercept is 5, right?
Yes.
Yes? We good with that idea?
Yeah.
Okay. When I look at when I look at A, what is my slope? 1. Do I have a slope of 1 here?
Yes, you do.
Yeah. Right? So it's not just, hey, the A is affecting the slope and the C is affecting the slope. It's that A and C are my slope, whereas B and D are the...
Y-intercept.
We all clear on those
I
ideas?
told you I carry this class. I'm the only one talking.
We are correct right now. Desiree, you good with that? Layla, you good with that? Shelby? Peyton? Jalea? You good with that? Okay. Corel? Okay. So, make sure, well, we're going to move on to slide 9 right now. I'm going to read through these directions together and make sure we're all clear on what the next little part is. But now is when you're actually going to be testing your predictions. And so each combination of f of x and g of x. First off, why are we using f of x and g of x?
Sorry.
Okay, Peyton. Why are we using f of x and g of x?
Linear exponent, or never mind.
Because you just picked it just because you want to.
Kind of, but there's a reason why I used f of x and g of x.
Because we've always used that. That's always been what we've used.
Okay, I want y'all to look at the backside of combining linear functions.
No, because A, B, C, D, E, F, G.
I'm missing an E. Look at number 1.
For equation.
What's on the left side of the equation?
Are you okay?
Yes. The left side equation on what number?
Number 1 on the backside.
Oh, on the
F
back
of
side.
x and g of x. H of x.
No, on the left is h of x, right?
Why?
Number 2, what's there?
Yes.
P of x.
Why?
Cookies.
That's what I'm asking you. Why am I doing that?
Because you just want to just code it.
No, there's a very important reason. We talked about this yesterday.
I know.
Yes, ma'am.
Input and output.
Well, so we're using function notation in general to talk about input and output, but why is it f of x and why is it g of x?
Because.
Why am I not doing y equals ax plus b? And y equals cx plus d?
Because I'm a f of x trying to find that times that equals that times that.
First off, that's not times. That's
F
f of x, meaning I substitute x in to get f of x out. But I want you to think about this. Is this function the same as this function?
Yes.
Yeah. No. They could be anything.
These
No,
could
but
be
they're the
anything.
same. They're the same thingy though.
What do you mean by the same thingy?
Like the same format. They're like both y equals and x equals b.
So they're both in slope-intercept, right?
Yes.
But are these exactly the same function?
No.
Corel, are they exactly the same function?
No.
No, right? A and C can be different. B and D can be different. Thank you, Peyton. You're good. Right? A and C could very much be different. So these would be different functions. Hey, f of x and g of x indicate that they are different functions. If it was just y equals, would you know they're different?
No.
No. But f of x is one function, g of x is another function. Number 1, it says what on the left-hand side of the equation? H of x, which means we have a third function.
What in the heck?
What do you mean?
I'm beyond.
I understand. I comprendo. Peyton, it's a different letter for different functions. Jeez.
Yeah, I got that. but
Alright then.
What is the h of x for? What specific?
We're about to look at it.
So there's.
For some reason,
That's
Okay, so I want you to notice here, Peyton, it says h of x equals f of x plus g of x, right?
Right.
To get h of x, what am I doing?
Combining g of x and f of x.
Through what?
Addition?
Thank you, addition, right? I want you to notice, it's harder to tell right now, but I do want you to notice, see how there's 3 different lines there?
Oh,
Yes.
gee, where'd you?
3
get
different
that one?
functions? It's the next slide, but hold on.
Oh, okay.
So, Peyton, here's g of x, here's f of x. H of x, is that the same function?
No.
So I needed h of x to indicate that it's a third function,
Right.
okay? When I look at the difference, right? Now I'm looking at, we should say p of x there, but p of x equals f of x minus g of x. See, I have 2 different functions to
Yeah.
start, and then I have a third one that is the difference.
Mm-hmm.
So I need a different letter there to indicate this is a different function that I'm dealing with.
Gotcha.
Does that explain everything?
Yes.
Julia, you good with that idea of why there's p of x and h of x and all that fun stuff? Corell? Okay, thumbs up for everyone who feels good about that? Bet, let's move on.
I'm insecure about my thumb.
What?
Nothing.
Did you say you're insecure about your thumb?
Yes, it's extremely short.
I feel like you should be used to that, but okay. Speaking from experience.
Well, my
But anyways, what I want you to notice is you're going to be exploring those different combinations. The second page provides a space for you to explain the connections you discovered between the operation combining the functions and the resultant function, right?
facts.
Do your best to explain how the features of each linear function impact the combination of and features of the resultant function, right? So when I look here, what were the features, the elements that we talked about? So we want to be thinking about how does the slope and the y-intercept affect h of x? You good?
Yes, I'm sorry. I just keep thinking about what incident.
Oh gosh. So we want to think about how the slope and the y-intercept affect the h of x. Also, you want to think about when I add and subtract h of x, what kind of function do I get? Because that was what your predictions were all about. When we did a sum, difference, did you expect it to be linear, quadratic, exponential, so on and so forth, right? Any questions before we get started? By the way, you can hit this little play here, and it just goes through the whole slider. And you can see it do lots of different options all at the same time.
Oh my gosh, that's so cool. Right?
Cool. Alright, let's get to work within your small groups.
Wait, what are we supposed to do?
Within your small groups, start on the slide 10, sum of linear functions. Figure out what happens when you add 2 different linear functions. What type of function do you get? And then after that, think through how do the intercepts and how does the slope impact everything. I'll write that up on the board. Y'all start talking.
Okay, add linear to linear something.
You did not pay attention.
Yes, I did. He said add two linear functions.
Well, yes, you're adding here, but it's already adding right here, Kelsey.
He said, what am I supposed to teach me?
It's a teacher, okay?
Oh, we're just supposed to move the sliders around?
In a way, sure.
Why is the black one moving with the red one?
Because they're added.
Oh, okay.
Yeah.
Oh my jeez, that's so cool.
Yeah.
How you make them all move at the same time?
You click play
You can't.
Yes, how?
What way?
On the side. Jeez.
What, bottom, top left, top right,
Look,
middle?
look. Right here. This play button.